Hey everyone, and welcome to this new lecture on the series of lectures on the inequalities. We basically learned a couple of concepts before in the previous lecture, and now we're going to go beyond the previous lecture. We're going to talk about graphing of the linear inequalities. We already graphed the linear inequality in one variable, and the graph that I'm referring to was called the number line. We talked about how a linear inequality could be graphed on a number line, and what do the solid lines and the what do the solid circles and the open circles represent. In this lecture, we're going to talk about linear inequalities in two variables, and most importantly, you're going to see a graph of x and y axis, the graph that you see in your everyday math, so that you can that you basically call in a normal conversation, that you basically refer to as a graph. So the first thing that we're going to do is that I'm going to go over the lecture, and this is what we're going to learn in this lecture. Basically, it's a lecture based on three videos, and after that we'll be done with the linear inequalities, and we'll be beginning with the binomial theorem. So what we're going to learn now is that how do we write linear inequalities in two variables, how do we graph linear inequalities in two variables on the coordinate plane that I was referring to, in the x and the y axis, and then we'll touch upon a little bit about a business and market research and inventory. Basically, these are examples of where you'll see the concepts that we learn in action. So we will begin with the vocabulary that we're going to use in these lectures, the stuff that we're going to use, the different terminologies that we're going to be using. I'm starting this in the beginning so that you don't, if I use these words in the lecture, so you don't have to, you won't be confused as to what their meaning is. So first of all, we're going to talk about open half plane. I'm just going to go through all of these without referring to what we're going to talk about, so bear with me. Open half plane is basically a dashed boundary line which separates the plane. You're going to see this, you can relate to this once we get to the graphs. And boundary, well, of course, this is pretty simple, the line that separates the half planes. Linear inequality, we already studied what it is, and anything that is not equal, even if it means equal or more than, equal or less than, whatever it means, it is going to be an inequality if it is not an equality. And solution to inequality, any ordered pair that makes the inequality true. This is pretty much the example for this is pretty much the case for any of the equations. Then the graph inequality will be the graphing of the boundary line and the shaded half plane that includes the solution. We will go through the shaded part as well, just wait a little moment, and then we're going to talk about the closed half plane, which is of course the solid boundary line that separates the plane. Now I want you to notice one thing over here. We talked about the open half plane, which is a dashed boundary line that separates the plane, and then we have the closed half plane, which is a solid boundary line that separates the plane. It's pretty much like what we did in the previous lecture, in which we had a solid circle and an open circle to represent different types of inequalities. So over here we have basically closed half plane and open half plane. Of course, there's a bit of a difference in these two terms. Well, the major difference is that is the frame of reference. I mean, we're using this in two variables, that was in one variable, inequality in one variable. So of course there's bound to be some difference, but I was just making a relation for you to understand it in a better way. And test point is basically a point which is not on the boundary line. Remember this and memorize it if you have to. There is a reason why not NOT is in capital in block letters, and because this is really important. Basically it is a test point which is not on the boundary line that I used to test whether to shade above or below the boundary line. Now I have used this word shade twice now, and basically this is going to make more sense to you once we actually get to the graph, and once we actually get to the plotting of the inequalities. Then you would know what a shading of a graph means. Now moving on, let's talk about graphing of the linear inequalities. So there are a couple of rules that I want you to make note of. Basically this is just to show you the concept of how to graph an inequality. Basically we have to start by treating inequality just like any other equation. We have been treating inequalities like equations in the previous lectures as well, because that is how we have been finding out the solution to the inequality. Once we treat the inequality like an equation, we need to an equation in order to isolate y so that we can solve for the inequality. Once we solve for the inequality, then only we can know the answer to the questions that are being asked. So this is the first step that we have to do. Now I think we all remember this, that in the previous lecture we talked about in the inequalities of one variable, we talked about how a solid circle on the number line is going to be a solid one or an open one based upon the type of inequality that we have. So if we have inequalities like under, less than, or greater than, or not equals to, then it will be a dash inequality over here in the two variables. On the other hand, if we have that point is included inside the solution, that is we have less than and equals to, greater than and equal to, then the boundary line will be solid. Pretty much like the ones that we did in the previous lecture, the solid circle and the open circle. Just like that, we have the solid line and the dashed line. It's all based on the same concept, that the answer that we have in front of us is, that is, the answer is that y is less than 3, and the solution is that all the numbers less than 3 is the solution to the inequality, then that would require a dashed line or an open circle in the previous lecture. What that means is that the 3 that in the example that I'm telling you right now is 3 is not included in the solution. 3 is not part of the solution. On the other hand, if it was that y is less than or equals to 3, then that would mean that 3 is actually included in the solution. That is, y is every number that is 3 and less than it. So that in order to represent that fact, we use a solid line to represent it in a two variable, like we are going to use it over here, or we use it in a by the help of a solid circle in the previous lecture that we did. Now, in order to know where to shade, now once again, please don't be confused with what I mean by shade. I'm going to go through this with you so you would know what I mean by shading. In order to know where to shade or what area to shade, we need a test point to determine the area of the shading. Or if once we get to the concept of this, once we understand how the shading process works, we could know that anything less than will be shaded below y and more than will be shaded above y. And as far as less than equals to, more than equals to, the only difference is going to be that the line of y, the line of the inequality, sorry, is going to be either dash or is going to be solid. So that is only difference. But once we get to the shade, till we get to the shading point, just bear with me and try to understand what I'm saying. Of course, I'm going to explain to you what this shading means. Now we have an example in front of you. We have to find out whether the boundary line is going to be solid or dashed, and before that we need to find out the coordinates that satisfy each inequality by testing these points, that is the testing points. This thing is pretty straightforward. If you want to know whether these particular points satisfy the inequality, all we have to do is we need to substitute these points and we can get the answer. 3, 5, we put in 3 for x, 5 for y, and we find out the answer, and the answer is -9 is less than 0. If you do you plug in the values, you do your calculations, you move stuff around, and you get the answer, and then the answer is going to be -9 is less than 0. So we know that 3 and 5 is a part of this equation. 3 and 5 will satisfy this equation, and that is A. Now we find out for 4 and 0, we plug in the values, we do our calculations, and we find out 8 is less than 0. So we know that this is not the solution to this equation. And once we know that this is not the solution to the equation, the boundary line is going to be dashed. Remember this, the boundary line is going to be dashed because 4, 0 is not equals to this equation. It's not a solution to this equation. Now let's take a look at another one. 4y minus x is greater than or equal to 6, -6, sorry. We plug in the values, we put in basically -6 for y, -2 for x, and then we solve this equation, and we, after doing our calculations, we find out that -2 minus 6 is not a solution to this equation. That is, if we have the values of -2 and -6, that is not going to be a solution to the above equation. Now we move on and we plug in the second values, and we get that 0, 0 is a solution, and thus it is going to be a solid line. Now let's look at a graph. Now this is where you have to give all your concentration. Now we have a graph over here, y and x-axis, and we have an equation, y is greater than 3x minus 5. So let's now plot it. Now we know that we knew about the equation of the format y is equal to mx plus b, so mx plus c, sorry. So over here we know that m is going to be 3. We know this from the equation. So up 3, right 1. Of course, I mean, this is how we can do it, but we know this for a fact that m over here represents the gradient. Now if you want to find out the y-intercept, I mean, this is the basic, this is a really basic way of solving this equation. This is a really basic way of plotting this graph. So we know that in order to find the y-intercept, we have to put x is equal to 0, because only on the x-axis can we find the y-intercept. At that, only at the y-axis will you find the y-intercept. At that point, x is going to be 0. So we plug in 0, so we get y is equal to -5, and because it is greater than -5, we have a dashed line. So we now put one point over here where we can find it, and the rest, you know, we can, the way to do basically this, basically the way to do these is that you make an x and y table, and you plug in the values of x and you plug in the values of y, and you get this and these points, so that you can make a graph, so you can make a line of these equations of this inequalities. So once we form a line of this inequality, we can know what this inequality looks like on the graph. So this is how it is. So this is how what this inequality is going to look like. And since we know that the boundary line is going to be a dash boundary line, we plot this with a dash boundary line. Now we check, we put in 0, 0. Now this is the point where you will find out what shading of the graph means. When you put in 0, 0, you're going to get 0 is greater than 3 into 0, -5. We're basically substituting any point, that is, we want to find out any point over here in this region and over here in this region. Now when we have to shade something, we shade it either, basically this line represents the boundary of the shading that we have to do. So this shading is going to represent go in either in this direction, or it's going to go in this direction. We can't shade the whole graph. We're going to shade this area that is to the left of this line, or we're going to shade this area that is to the right of this line or below this line. How do we find that out? We find that out by plugging in the values, that is 0, 0. We plug this in. We try to find out whether this satisfies our requirements for the shading, or which area of the graph do we need to shade. So we plug in 0, 0 to this example, and through this we basically find out that 0 is greater than -5. So we know this is the answer to this equation. After plugging in 0, 0, we know that 0 is greater than -5. So now we know that this area of the graph is actually the one that this equation is representing, that is y is greater than 3x minus 5. So this is that area that is being represented by the graph. So we shade the same. We can shade this with the help of like a coloring pencil, or just a pen or pencil, whatever you want to use for that. You can use this and you can actually find the solution to this equation. So what this graph basically now represents is, well, there you see there are basically three things that this graph is representing. First of all, this graph represents the equation that we are dealing with. For example, we are dealing with y is greater than 3x minus 5. So this is what this graph is representing over here. This line, this dashed line, this is what it's representing. I mean, we already talked about the dashed and the solid line. Since we have greater than, only greater than, so we're going to represent this with the help of a dashed line. This is the first thing this graph is representing, the equation of the line. The second thing this graph is representing is, of course, the dashed or solid line, whether this is greater than or greater than equal to, whether the points on the graph are included in the solution or they are not included in the solution, or all the points will be greater than the solution. All the points not on the line will be the part of the solution. This is what is representing over here. The third thing what this graph is representing is the solution to the equation. That is, all the points above, or on the left side of this line, are the points that satisfy this equation. And that is did we find that out? We took a point from this region. Well, actually there's just two regions over here, right? So we took a point from this region, any point. So we took 0, 0 because that way it would be easier, because that way it is really much more easier for us to understand and much more easier for us to calculate. We took one point over here, we substituted it, and if we got the answer to the equation that is over here, then that way we would know that this is the equation to the this is the answer to the equation. On the other hand, if we would have chosen any number from here, like let's just say 5, 0, well, if we took 5, 0 over here, that would basically give us 3 into 5, 15 minus 5, that is 10 on this side, and 0 on this side, that is 0 is greater than 10. That is not the correct answer. So that is why we know that this is the area why that represents the solution to this equation. That is, these are the values that would give us that would satisfy this inequality. So this is pretty much it for this lecture, this video. The lecture still continues in the next video. Hopefully I'll see you then.